This video is in support of the 4347 JDBC project, the game version, and we're going to go over each step in setting up the project, executing, testing, and finally packaging the project for to be turned in. We're going to start with the setting up the project. So we're going to you have to use Eclipse for this project, the way it's set up. And so this is the latest Eclipse version, and it's a brand new workspace. And I'm going to import some projects that were provided. So on e-learning, you were provided the the project description, evaluation sheet, and 2 zip archives. I'm showing 3 here because I'll be using the, an additional one, but student and project testing. So let's import those first. Again, you can find these on e-learning. So to import a project, well, there's a couple of ways of doing it, but I'll right-click. Well, it doesn't work. Never mind. I'm going to go to File, Import, and then under the General category, Existing Project, Next. Now it's important that initially, by default, Eclipse will have select root directory, and because we'll be importing from a zip archive, you must import selected archive. If you mess up and browse to the zip archive and do the import, it'll seem to work, but the project will not be set up correctly. Anyway, so select archive file, browse to, and then I'm going to go to the actual folder where I have this stuff. Okay, again, this is all. Wait. So let's first import the student dev. Right there, develop student project. And there it's slow because we're reading from the share drive. And then finish. And there is the student project. And then we have to do the same for the testing. Existing. And browse to, and then the testing. Again, this is very slow because it's loading off to share. All right, but nonetheless, we have both of them. And I guess the one thing that we make sure of, although it's clearly working, is that the build path of the testing project. So you go to build path, configure build path. Under projects, that we have the student project is referenced by the testing project. Oops. And so let me look at my notes. Okay, we're going to come back to that. In this section, we're going to go over the setting up the database, the schema. If we look at the project description on e-learning again, we see that there's a lot of verbiage. But here is a UML diagram of the schema you must produce. This, of course, is a UML diagram. This is very similar to the SQL project that you had to put together. SQL programming project, the first question where I had you use the UML, translate the UML diagram to a schema using the MySQL workbench. So this is the schema and UML, and so I'm going to start workbench. Okay, so I'm going to use localhost instead of my AWS database because it's going to run much faster. So connect to localhost. So I have already completed the design of the schema in Workbench and exported the SQL file just like we did for SQL Programming Project 1. There's a video on YouTube that went over that process, and so I'm not going to cover it in this video. Instead, I'm just going to import the SQL file that was generated from the model file, the MySQL Workbench model, and I'm just going to drag that into Workbench, and there it is. Okay, so and then I'm going to run it just like we did for the, as we demonstrated, we dropped the, as you did for Sequila, drop the SQL with the create tables in into the Workbench. Something that's very important, and I go over it in the description, is the name of the schema must be games for testing purposes. So although you're free to name the tables whatever you want, the schema does have to be named games, as shown here. So I'm going to run the schema. Oh, my bad. I had something selected. Try it again. There we go. And so then if you refresh the schema view, we see we have what are my tables, my implementation. You could have different table names if you wish, because all of the SQL is encapsulated in the DAOs. If we examine their contents here, and we look at the tables, we'll see there's no rows in it currently. We'll be populating the tables in a bit. Okay, go on to the next section. In this section, we're going to briefly go over the development project. There are two projects that you need to install in your Eclipse workspace: the development project, where you're going to be coding, and the testing project, which we'll talk about next. So in the development project, we have pretty much the structure of the system, the structure of the program is very well laid out. So we have a set of DAOs, interfaces that correspond to each of the entities in the problem domain in the UML diagram, and which would be reflected in the tables you generate and with the foreign key relationships, and then exported and installed in your workbench schema. So the each of these DAOs is concerned with saving one of these entities from the game, and those entities, I should have started with maybe, are in the entity section or package of the project. So this is provided. Each of these 5 entities that are, in the problem domain. You can't change this code because if you do, you'll break the unit test that we'll talk about in the next section. So much of this code in this project cannot be modified. We'll talk about what you are to modify in a second. So for each of the entities that I've laid out in the entity package, there's a DAO responsible for crediting instances of those entities. So we have the DAO interfaces and we have the service interfaces. Again, these are laid out. This is, my design, and it cannot be changed because if you change the, let's say, the method names or arguments in any way, the testing project won't work. The unit test that I've laid out will not work, and then I can't test your submission. So these are the service interfaces, and then we'll talk about implementation in a second. And then in the util package is just an exception and a testing program that you can have a look at, but it's not important. All right, close these. All right, so what do you, you can't touch much of this code, what can you? Well, in these implementation packages, DAO implementation, and in the service implementation, we have classes that implement the interfaces. So I have those set up already. And if we examine each of these, we'll see that we have the method, the interfaces have been implemented. So here we have game DAO implements the game DAO interface. So I have the methods, but they're obviously not implemented. And throw an exception if you call them, without having implemented them. And so that's the major effort of the project, to both implement the DAO methods, implementation methods, and then in the services, we have the same thing. Okay. So that's the task to be implemented and divided up amongst your team members. And let's see, I'm looking at my notes. Okay, well, anyway, that's the structure of the program and what essentially what teams are to implement. In this section, we're going to describe the second of the 2 projects, the testing project. So in this project, you're going to find some things such as the MySQL and other jar files that must be included, the MySQL JDBC connection implementation jar file. All of this comes configured when you import the package. Also, there's 2 source directories. There is just a normal source directory where we have some utility code that I provide, obviously you'll need. And then the test source directory, we have 2 sets of unit tests, JUnit test cases. One, a set of test cases that exercises each of the DAO implementations. And then under the service package, we have 4 test cases for each of the service classes. And none of this can be changed. Well, none of these test cases can be changed. You have to work, make them work on your own, so to speak. If you change the test case in your project, and then you turn in the project, I will be testing with an unmodified version of this testing project, and so my test will fail as they won't, or the original test will fail as they won't match your modified test cases. So you can't change the test cases. It's long and short. You can have a look at these. It's a JUnit test cases. Each of them is a JUnit test. It's annotated with the test annotation, and it tests some aspect of the of the execution of the implementation of that particular DAO or service class. So that's the unit test, and we'll demonstrate how to run the test cases later. But right now, what we need to have look at a little bit is these two utility classes that come with the test case. There's the data source manager, which we talked about in class, and then another utility called populate tables, which is used to populate test data into your schema prior to testing. So let's talk about data source manager first. So it's really not much, nothing needs to be modified in this class, but what needs to be modified is the configuration. So the data source manager, when has an initialization, lazy initialization that will read a configuration file, dbconfig.properties, when it's when it's initialized, and so this is where the data source picks up the parameters it needs to to connect to your server. So this is dbconfig. We talked about this a little bit in class. So this has 3 properties, and be sensitive about putting spaces between it. So this is not a good idea. Won't hurt it. Well, there was a problem I worked around, but yeah. So the URL where the server is running, and in this case, in this demo, I am running the server on my local PC somewhere here. This big mess of various symbols. There's a MySQL running. Oh, it's right there. If you were to modify your, if you're using AWS service, which is, this is why we're doing it, no problem. I'm not sure I want to demonstrate that because I don't have it handy, my AWS URL. But this is where you would substitute localhost for your the name, the DNS name endpoint was the term AWS uses, just like you set up for your workbench. So I guess I could show that. Here's my workbench. Here's my AWS database server, and if I edit that, recall this host name. This is the endpoint name that we loaded from the AWS MySQL properties page, configure manager page. And so this address would be inserted right there, just like that. 3306 probably won't change. And then these 2 properties, if you will. Oh, then you have to have /games. This is the name of the schema, and you have to name your schema games. And then allow public key retrieval equals true, and use SSL. Oops, went past it. Use SSL false. You just have to, this has to be there. Okay, just as shown, just as provided in the testing project. Okay, so that's how you set it up for AWS, but I'm going to go back to localhost. Again, because I'm running the PC locally. And then I'm going to set my, and this is called root. Yours would probably be admin, and then whatever password. That's my throwaway password. All right, we're going to save that. So now, looking at my notes, so now if you want, I would suggest we have our, I would suggest testing this data source. So before we can do that, you have to have the MySQL server running. Well, let me close that. And so let me bring it back to here. You have to have the game schema loaded. And that's all really it. So you can't run this test until you have a schema named games installed on the on your server. And partially that is because the DB config properties, that's the name of the schema right here. So everything after the address, but before the question mark, is the schema, default schema, and it's set to games. So when the data source manager builds data sources connections to the server, it's going to use this schema as the default. So where I'm going is on the data source manager, I have a simple little test program that is going to run a query against the attempt to connect to and run a query against your server. And this will just test to see if your properties file is configured correctly, and because if it might be hard to debug, while running the test cases. So let's run it. Take run as application, and it worked. Now, if you basically you have to have this query has to run correctly too. So this is the name of any table in your schema. I have in my schema, it is game. See right there, game. If I change this name to game X, or if I don't have a table that matches a table in my games schema, so I'm going to say game X, and then run it. Just run it from here. Yeah, you get an error. That's because its game X doesn't work. Although this is an indication that the connections are working, because it wouldn't be able to connect to. If you were to get, if your server wasn't running, or if there, for any reason this test data source manager test case can't connect to the server, I'm just going to rename give it incorrect address and run it again. You'll get a little timing error. Ooh, trying, can't find it. And then you'll get an error like unknown net host exception, or if you give it the wrong password. Another error, you get an authentication error, access denied for root at, and so on. So these, if your server or ID and password are not configured correctly, then when you run this data source manager test case, you'll get some sort of SQL exception that should describe the problem, and then from there you can debug it. But when it runs correctly, when it's working correctly, you should just get a just something like that. Okay, looking at my notes. Oh, okay. Then the second program in the project, I'll put that away, is this populate tables utility. So, as described in class, this utility program, will connect to the database and will load test data into your database, your empty schema that you built with your script, and will inject games and credit cards and players into the schema. And the key point is that before you can run this program, you have to have each of your DAOs implemented. Not the entire DAO, but you have to have implemented the here. You have to implement each of the create methods. So credit card, create, games owed, create, and so on. I give an implementation for player example. So again, you have to implement the create method, not the entire, all the other methods can be left unimplemented. But in order for the populate tables utility to operate, it has to be able to insert new rows. And to do that, that's inserting new rows is the responsibility of the create methods on the DAOs. Okay, so again, we'll show an example. I'm not quite ready. This setup is not quite ready to run populate tables. We'll show that in a bit. But just want to point out this is a very important step in executing the project. The ability to, before you can run the test cases, you have to have some data in the tables, and that is the purpose of the populate tables utility. And we'll demonstrate running it in a second. Okay, that's it. Okay, in this section, we're going to demonstrate running the populate tables utility. Again, the purpose of populate utility, well, the utility is found in the testing project, source, and then populate tables. Okay, in order to illustrate or demonstrate running this program, you have to have implemented the DAO classes, the DAO implementation classes. You don't have to have them all. Again, all you have to have in your student development project is, is to have the create methods only, because they'll be used to insert the rows into the corresponding tables. But these aren't implemented in your development project in student dev. However, I have my own version of the project that is implemented, of course, and so I have implemented all of the methods, including the create methods. So I'm going to make a change to this project's configuration that you will not be doing, but I'm just demonstrating how it works. So I'm going to change the build path of the testing project, testing. And I want to reference my completed project. So I'm going to remove testing and add okay, so now the testing project is referencing my implementation. Again, you will not do this clearly. I hope it's clear, but you will have to both before you can run populate tables, you have to have a data source working. So you have to have had your data source manager and then modified your configuration properties, ran the testing utility provided by data source manager. And if that worked correctly, then then you're ready. Then you have your data source set up, and you also have had to have your schema prepared and loaded into your workbench, into your database. And also we can see here that just demonstrate here that this, although we have these tables, there's no rows in them. So we'll be inserting rows into these tables with populate tables. And looking at my notes here. And so let's just run the program with everything having all those prerequisites having been set. We're just going to run this program, populate tables. And just that quick. Now, if you're running on AWS, yours is going to run much, probably 10 times slower. That was very fast. That, in a sense, as you can see, it said it built the players, inserted, built 100 games, inserted them, and again, for each of the entities, it built an instance and then inserted them into the into the database using the create methods of the DAOs. And so let's go back to Workbench and let's see if this works without contortions. There's a bug. We talked about this before. Select all. I have to do this weird thing. I could restart and then let me see here. What is it? Analyze table. Okay. And then go back to summary list and then refresh. There we go. That's what we're looking for. So in you should see these row numbers in your newly populated schema. Again, populated by running the populate table utility. If you run this twice, so we have, here's the workflow. We have an empty schema. We run populate tables, and now we have these numbers. If we were to then run this again, we would have, basically double the number of rows, and that might cause problems with the test cases. So just a word of advice, if you're having difficulty with some test cases failing, what you might want to do is go into Workbench, as we see here, and we see something. Drop the schema. I'll demonstrate it. Drop schema. Drop now. Schema is gone. Now we need to load our schema into Workbench. So I'm going to drag my exported schema file. I don't know why it's not refreshing. I don't know, it's just always something. Anyway, but it seems to be loaded. That's odd, isn't it? Anyway, it's loaded. Then we run it. Make sure nothing's selected. No text is selected. Run it. And refresh the schema. Tables. This is the old one, so let's get rid of it. And tables. Empty. Then run populate tables again. Inserted the rows. Man, I wish this worked. Wrong button. Select everything. Let's see if it just refreshes. Doesn't work. Oh. Back to summary, refresh, and there we have the rows we expect. Let me look at my notes here. Okay, so now we're ready for testing. So let's move on. Okay, in this section, we're going to describe how the project is tested, how the individual DAOs implementations are tested, and how to test them individually and as a package. So here we have the testing project, and um, so let's look at a test case. So we got credit card test case. So this is a set of test cases under test source, JUnit test cases, and each in this test case class, we have test case methods, and they're annotated with this test annotation. So if we look at each of these methods tests a different aspect of the DAO implementation's features, and they're kind of self-explanatory. I'll go over a few of them here. So the way the test case works is in the method we get a data source from the data source manager. So that assumes, of course, that the data source manager is properly configured. And remember, the data source manager was provided in the testing program, and it is configured with the dbconfig properties to connect to your wherever you're running your database, and through the URL and the ID and password. I'm running mine locally. It runs much faster when you're running MySQL server on your local machine. But at any rate, so we get a data source, and then from the data source we get an open connection, and then we set the auto commit, for the transactions to false, which is pretty standard practice. And then in the finally block, as we've talked about, we didn't talk about this. We want to roll back the transaction. So by turning off auto commit, the changes, in this case an insert, because we're testing the create method, the insert of a new row into the credit card table won't be committed because we're going to roll back the transaction. So we don't want to commit the changes that are being made by these test methods to the database. This is just my idea, put auto commit back to true, but it's up to you. And you don't want to change this code. It's just something I do. And then we close the connection in a finally block. So just to make that point, you can't change the test methods to fit your implementation, because if you make a change to the test cases to get your particular implementation of the DAO or the services to work, well, I won't get those changes. I'll be testing against the original test methods, and hopefully that's clear. So then we get the credit card. We get an instance of the credit card DAO implementation, and then this is where we're going to take a little sidetrack. There's let me explain what's going on here. We need a player ID. So if we look at the object model, we see that the player has associated with it a list of credit cards, and this is to be implemented by the DAO. So in order to add a new credit card to the system, we need a valid player ID, and we can only get player IDs from the database, from the sample data that was loaded when you did populate data. So I had some luck with them off screen here. So we have the credit card has, in this case, it's a weak entity, but I have an ID anyway. It really makes no difference. But here is the foreign key reference to the player. So in my case, that foreign key is named player_ID. You might have named it something else. And because the test cases can't know what you've named your tables and or named the attributes of those tables, there is a utility class also provided in the testing project. Oh no, I'm sorry. It's in the implementation project. So I'm opening up my implementation. In the student project, let me close that up, open that up. Oops, wrong one. Opening source, util. So in the util package of your student or in my implementation, there is a class called testing utils. And testing utils provides a number of methods that are used to obtain valid IDs from the database. So this is my attempt to fully automate the testing, the unit testing of your implementation. So what it amounts to is that there is a methods in this. Well, it's really just they're static methods, so they're really much more or less functions in this testing util that will do a select on the tables, and in this case returns a single valid player ID from the player table. So the only way to make that work is because, as I said before, each team's implementation might have different file names or table names for the player or the player's ID and so on. So we need to have a testing case that incorporates those, or a testing utility that includes an SQL select to retrieve the correct attribute name from the correct table. And so there is a get player ID and there's a get game ID and select distinct play games played, and you can look at these. Each of these utility methods is accompanied by an SQL stream. So this is my implementation. If you look at the student unimplemented method, you see that these strings, these SQL selects, are marked to be added by student. But what I've provided for in each case is a sample select which works with my particular implementation, my particular schema. And so what you need to do is you can use this template, select ID from player. So this will select all the IDs from the player, in my case, the player table. And so you would substitute your name for, the name for your player table and primary key attribute name, and then this will work. It goes out and creates a statement, prepared statement. Oh, I just use create statement. That's interesting. Yeah, I'm not using, because there's no substitution here. And so so I'm just using statement because I don't have to do any substitutions. This is, there's no parameters in this query. Anyway, execute the query, get back a result set, and then I select and return the first n items in the result set. and then this method this is get player IDs, returns a list of longs. This returns just the first list, the first long in the list, or the first player ID. And there's a pattern that's repeated here. So each of these methods in the testing util has a sample SQL that has been written for the specific schema, and then a string that you need to copy and paste into and modify to match your particular schema. There's a more complicated one, but here you'd have to substitute that and that and that, to match your particular schema. Oh, and here's an example where I want to say get distinct played games, from the played games table, from the games played for a particular player. So then I am using a prepared statement because we're substituting the ID of the player whose we wish to get the games played ID, or the primary key of the games played table. Anyway, that's what you need to do to facilitate this automated testing that is has been provided with this project. Okay, so close that. Looking at my notes. So in this project, let me close some of this up so it's not too confusing. We have the source with the two utility classes which are provided, we've gone over, and then we have a second source tree for test source. This is a common practice to put your test cases in a separate source tree, and we have a number of test cases for we have 5 DAO implementation test cases for the 5 DAO implementations, and we have 4 service implementation test cases. And generally, the way these test cases work is they just talk about this one in general or specific. So we're going to, as we said before, these methods get called automatically. Let's illustrate. So we can select and then run as, and then a unit test. And then it runs very quickly because it's on my PC. It runs each of these test methods, and if they are successful, they're green. And if there's an error, they'll turn red. So if we can illustrate, let's see, find one that is we can suitably find one that's easily broken. Well, here's one, I guess. So let's look at this one. Test retrieve is a test case because it's annotated. Get the data source, get a connection, turn off auto commit, build an instance of the DAO implementation that we're testing. Then get a valid player ID because we're testing credit card. And then let me point out something. We're testing retrieving the credit card. So the way I have this set up is we first build a credit card, a new credit card, with that player's ID. So how do we build a credit card? Well, we have this utility function provided in the test case that creates a new instance of credit card, populates it with some sample data, and then returns it. So that's how that works. So now we have a new instance, uncommitted, unpersisted instance of credit card. Then we call create credit card, and so create returns the credit card that was inserted, but the create method, adds a ID. Anyway, so then we get the ID, so that's credit card 2. We get the ID for credit card 2, and then we create another credit card. I'm sorry, then we retrieve. So this is where the actual test is happening. We create a new credit card, we insert the credit card, and we have a reference to it, and then we retrieve the same credit card a second time and assign it to CC3. So we created, inserted, and then retrieved. So now the test is that the values retrieved in the credit card that was retrieved in CC3 will be identical to the credit card that was created. So the create inserts a new credit card, we retrieve the credit card, and then we compare credit card 2 to credit card 3. Wish I could point at these without this pop-up happening, and that's what we're doing in the rest of the method. In this first assert, we're asserting that the credit card is not null. That this retrieve returned a not null credit card, and then we're comparing each of the attributes of CC2 to CC3. They should match. They should have the retrieve credit card CC3 should have the same ID as the one we asserted. The player ID should be identical, and all of these. And that's what assert equal does. It asserts that this value is equal to that value. So if we want to see a failure, I'm going to do something like, I'm just going to say -1, -1, L. Okay, so I just, changed it to a failure. Oh, it doesn't like that. Why? Oh, it's 2 objects. Player ID. All right, let me fix that then. So it's just something like new long -1. That should compile. Doesn't like it, but it should compile. It must be a deprecation. Yeah. Oh well, we'll live with it. And let's run it. So now we're going to run this set of test cases again. And look, on test retrieve, we have a failure. And so it's marked as a failure. It's red. I have a failure here. And then if we click on it, it'll take us to the method and show us, what the problem was. Yeah, okay, so we, where -1 is not equal to whatever that player ID is, and so we see the failure. If there was a problem with your implementation of retrieve, then you might return a different player ID, or if you weren't retrieving the credit card number correctly from the result set in the DAO implementation, then these two wouldn't match or something. Each of these asserts is testing that, again, the credit card retrieved from the database is equal to or the same credit card as the one we inserted. Okay, and that's the general pattern for, you can also repeat the test there. That's the general pattern for each of these test cases in, in each of these packages. The service, does kind of the same thing. I'll let you look, these over. And if you have questions, of course, ask. And so again, just to make sure, you need to implement each of these queries in the testing util for this automated testing to work. And if you don't implement it, then you'll get errors. Okay. Looking at my notes. So, and then what it amounts to is testing. Each team member testing their the classes they've implemented, the services and classes or DL implementations they're responsible for. So again, if somebody is building the let's say the game DAO, if you've divided the effort amongst the team members, and some team members, if one of the team members is, responsible for implementing the player DAO, then they could focus on running this DAO, just run as JUnit test and focus on getting their test to work. And individually, every player could be responsible for seeing that the test cases, both the DAO test cases and the service test cases, that they've, let's run that one. And there, that one works too, are working correctly. But at the end of the day, all of the test cases should work. So you can run the whole test suite or individual packages by clicking on the appropriate package and say run as JUnit test. And so you can see that this ran every test case and every method in those test cases. So it's a good way of running all. And this is how, essentially how I'll be testing is, after loading your jar file and for this and linking your jar file against this a testing project, I'll run the test cases and this tests, the tests that work will be great. And if there's tests missing or tests broken, I should say, then there'll be some penalty. Now, generally, the penalty would be assessed against the student that was the team member, I should say, that was responsible for implementing that DAO or service. And I should talk more about that during the lecture. Looking at my notes here. Remember that, so the things that must be done to successfully run the testing is, of course, you have had to implement the DAO implementation classes, and the service classes were appropriate. You have to successfully run the populate tables utility. Well, you'll have to have your schema finished and then, create a new schema in your, I think I have, I guess I don't. I thought I had MySQL Workbench open, so I'm not going to open it. You have to have your schema working, then populate tables with the fully completed DAO implementations, and then you can start, the testing. Looking at my notes. Be careful if you run populate tables twice, you'll end up with more rows, but that might not be a problem. Just keeping in mind that if you're having an issue, you might consider dropping the schema, rebuilding it, repopulating it, and then run the test again. Okay, well, that's it for this section. Okay, so this is the last step. And so what you need to do is we'll explain how the testing will work. So I'll have my testing project in an Eclipse workspace, and I will load the jar file you provide. We will not be attempting to compile, although I am asking you or requiring teams to submit their implementation project. I am not going to, I am going to inspect certain DAO implementations to see if the work was being actually done, but I am going to test against a jar file exported from your project. So we're going to go over how to export the jar file and the project and how I'm going to test with it, something you should repeat yourselves before you submit the zip file containing the eval sheet, the SQL script, the jar file that we're going to export, and your implementation project, which we'll show how to export here as well. So what we need to export a jar file. from your project. Now, you would be exporting from your student project, but I'm exporting from my implementation. So just another export, but instead of general, it's under Java. You're going to export a jar file. So click that, and it'll select your project. And I think all the defaults will work fine. And then you need to, I'm going to browse to it. So I'm going to, this is a different course. Team 99, I don't know, whatever you want to call it, doesn't really matter. And I might have a pattern in the course doc description. I'm just going to call it games. I don't know, games. That'll do fine. Team 99. Just make sure you have team number on it so I can make sure, things don't get mixed up. And then save. And then finish. And so in that directory, whichever one it is, that is strange. It should be there. All right, let's have another look at what I think I just did, but I don't think I did correctly. Export, doc, jar file. Oh, let's see, I didn't. Yeah, that was wrong directory. So I'm going to go to where I want to put it. This PC, C, temp, so I can find it later. And same name. And then here we have it. Okay, so how do so what I would recommend is that you run the test cases again, but not against the implementation project, which you would have been testing with up to this point, but against the jar file. So the way you'll need to reconfigure your build path, class path. So build path, configure, and so the project is on it, so we need to remove that. And then if we apply and close, we'll get an error because there's no implementation. So then we'll go back, and just to illustrate that there would be an error, go back to configure. Under okay, I didn't rehearse this. The first thing you need to do is you need to drop the jar file into the project so you can reference it. So there it is. It's now copied into the project. Then we go to build path and configure. Projects is empty. Libraries, add jar, and then navigate to it and apply and close. And then all the errors have gone away because now we're linking the testing project against that jar file. And then we just do what we did before. We can just run the test, and everything should be, should run the same as, for better or for worse, as it was running against the test when they were run against the implementation project. So JUnit test, and just, there I ran them all. So that it means that you have a jar file that is suitable for testing. The only other thing you need to do then is to export your implementation project. So you want to export the project, and then here we're going to go back to general, archive file. So just like the import, now we're going to export archive file, the project you can export. Then I'm just going to rename it here. The directory you want to drop it into. Again, this is from a previous class. Team 99, game, JDBC, and then finish. And then in that directory, did I not do it correctly again? This is getting old. What am I doing? Archive file, temp. Oh, it's in cancel. It was up a level. Yeah, right there. Put it where I want it. Okay, so now we have the jar file, and you have your exported project file. This plus your again your schema, SQL, and your completed evaluation doc get all zipped up into a bundle, as according to the project description. And this is what you drop into the zip file is what you drop into the project submission folder when you're ready to submit before, of course, the project due date, which again is in the project description. Okay, so that's it for the project, and good luck with it.